ISIS, the routing protocol you never knew. So we're moving from OSPF into ISIS, essentially the most popular routing protocol in the world, to the least. So you might wonder, why are we talking about ISIS? What is this protocol anyway? Well, that's going to be what we cover. It is actually a very popular protocol among service providers. In its niche that it fits quite well. So we'll look at its design, and then the big thing is comparing it to OSPF. What's the difference? What features does ISIS have that OSPF doesn't, and vice versa? Here's a little known fact. The OSI model, you know, the one you learn when you first get into networking, please do not throw sausage pizza away, physical, data link, network. You remember, you memorize the layers and that kind of thing. That was never meant to be just a model. It was actually designed as a protocol, the OSI protocol. As a matter of fact, it was a major competitor against TCP/IP. And it's very similar to the old VCRs. Remember, before there was DVD players, we had VCRs, and there was two formats of tapes. There was VHS and there was beta. I sure hope, as I'm having this conversation, that you're all like, yeah, VCRs, I remember that, and I'm not. For some reason, I feel like, is this one of those moments where somebody goes, "What's a VCR?" and I feel very old. Hopefully not, but nonetheless, does anyone know, if you know what a VCR is, what format of tape was better? Beta. It was the smaller tape. It actually had higher quality video, but VHS won. I don't know why. It was mafia involvement, I'm sure, but it's the same way with OSI and TCP/IP. OSI, although there could be arguments for and against it, I believe was the better protocol, but TCP/IP won, and it still rules the world today. And ironically, if you look at OSI versus TCP/IP v6, you can see that TCP/IP v6 actually adopted many of the original, I mean, like, we're talking 1970s time frame here, original things that they had envisioned with OSI, which is just, it's funny to see that happen. So nonetheless, OSI was never meant to be just a model, and TCP/IP, I mean, it had its routing protocol, right? OSPF, well, so did OSI. And it was called ISIS. Ah, that's where it came from. So ISIS was the routing protocol for the OSI protocol. Well, as we know, they lost, right? OSI didn't win, TCP/IP won. So why are we having this conversation? Well, what they've done is adopted ISIS, modified it to work for TCP/IP. Matter of fact, they even changed the name. They now call it integrated. I'll just put INT. Integrated ISIS. And when ISPs were first formed, this was a government mandate that you had to deploy ISIS inside of your system, because back then they didn't know which protocol would end up being the victor. And so they said, well, let's make sure that there's an ISIS foundation, thus making it a very viable protocol for service providers today. Now, at the end of this nugget, I actually have a complete breakdown of OSPF versus ISIS, and we'll find out who the victor is. But what I wanted to do was give you the facts about ISIS from the very beginning, and you'll see some of my comparison from the start. The facts about it is a link state routing protocol. So link state means it uses the SPF algorithm, the Dijkstra algorithm, just like OSPF does. It also has the entire database of routes that allow it to get around the network. It uses the concept of areas. So same conceptually-ish as the OSPF protocol. Forms neighbor relationships like OSPF with a hello protocol, but some advantages, more tunable than OSPF, and I will say faster than OSPF out of the box, although you can tune OSPF to be just as fast as ISIS, more efficient and more flexible than OSPF. We'll talk about why that is when I get to the comparison, but that alone, just as you understand that, is a pretty compelling argument. However, I will say more difficult to understand than OSPF. This is actually, I was going to go just on Google Images and grab some guy's fish tank, and I was like, you know what? No, I'm going to use my fish tank. So I went to out into my living room and took a picture with my cell phone of my fish tank. It is actually on its way out of our house right now. It is a 185-gallon saltwater fish tank. Now, I know what you're thinking. You're like, well, yeah, too much maintenance, right? No, actually, really easy to maintain. Couple hours a month, literally 2. I time myself to maintain this fish tank. Just changing the water once a month, feeding the fish every day. That's all I really do. But everybody that comes into my house looks at this giant fish tank and says, and says, wow, that must take a lot of time. And I feel good when they say that because I'm like, well, yeah, well, actually, no, it doesn't at all. And they're like, wow, really? It's that easy to do? And I go, yes, it's that easy to maintain this fish tank if you know what you're doing. You see this tie-in that I'm doing right now. ISIS is actually faster, more tunable, efficient, and more flexible than OSPF, making it, again, just like OSI was over TCP/IP, the better routing protocol. Then why are we having this conversation? Well, because it's a saltwater fish tank. If you know what you're doing with ISIS, you're like, man, this thing's awesome, and I can tune it and I can deploy it in a matter of minutes. However, the vast majority of the world lacks the knowledge to do ISIS, right? The reason why is because it's still built for the OSI protocol. So it requires an OSI address. It's actually called a connectionless network service, a CLNS address that you have to assign to your device. And essentially all the routers in the network find the best route to the CLNS addresses. This sounds a little weird, and I'm getting a little deeper than I had intended to, but let's go there for a second. When you use ISIS, I mean, think about OSPF. Let's just say there's a network here, the X network, right? And so with OSPF, all these routers are like, oh man, what's the best way to get to the X network, right? Like this is their focus. But in ISIS, you actually assign each one of these routers a CLNS address. And all the routers say, okay, I'm not really concerned about the X network. I just want to find what's the best way to get to that guy who has the CLNS address of such and such. And we'll talk about the addressing a little bit later. The fact is, ISIS just carries a little payload. Think of it like ISIS is the train, and attached to it is this little car that actually has some TCP/IP addresses in it. That's how they created integrated ISIS. Is they said, well, we're not going to really change the protocol other than the fact that it has this little train car with it that carries network X. Right? So when this router is running integrated ISIS, it's still trying to find the best way to get to all its CLNS neighbors, right? It just says, oh, by the way, CLNS neighbor, XJ5963, we'll talk about those addresses in just a moment. But that neighbor actually has a little train car attached to him that has this network X, which maybe is 192.168.1 inside of it. Now, I know some of you might be thinking, well, man, Jeremy, why are you getting rid of that beautiful fish tank? Kids, actually. I live in what I would say is a relatively small house. And this month, as a matter of fact, by the time you hear this, probably, unless you're very quick to listen in on these new videos I'm creating, we will have baby Chara number 5. Number 5, seriously, coming into our little flock. So once we reach that, we looked around our home, and by the way, we homeschool. Hey, how about that, right? And we said, what needs to go? And it was actually me. I know you're like, your wife said, no. I actually looked at the fish tank and I said, it's not going to fit, is it? And she goes, no. And so sad to say, it's off. So ISIS design. Let's talk a little bit about how do we think about this. Now, again, I want to compare this a little to OSPF, and I know in this SPNGN2 series, we just did an overview of OSPF, basic OSPF as you would call it, and it's the same way with ISIS. So you remember when I was talking about OSPF, I said in OSPF we have this backbone area 0, right? And that's where it all starts. You put your routers inside of there. My little chocolate chip cookie here. You create your area border routers, and you remember this? Area border routers, which connect to other areas, and these guys have the ability to do summarization. That's their special power, is the ability to take all the routes from this, we'll say area 1 over here, and you got all your routers and all this kind of stuff, connecting networks and so on. So all of these are maybe the 10.1 networks, 10.1.1, 10.1.2, and the ABR has the ability to do summary routes, and so it can sum up all area 1 as it goes into area 0. But there's a big constraint with OSPF, and that is everything must tie to this area 0. It's one location. It doesn't stretch. Now, you can bend the rules, if you will, and use virtual links, is what it's called, to kind of tunnel areas through to areas. But I mean, that's a band-aid. It's not meant to be that way. So you have this area 0 design constraint with OSPF. Well, looking at ISIS, what you have is 2 different levels of routers: level 1 routers and level 2 routers, and they are as different from each other as pre-plan differences as men are from women. How about this? Okay, Stop. They're very different, right? As in, they don't form neighbor relationships with each other. Level 1 routers, think of those as your internal routers with OSPF, right? Things inside of an area. So level 1 routers here know about all the routes in area 2. Now this is, you're looking at a picture here, which is just a diagram. This could represent 50 or 100 different routers in area 2. And they would all be level 1, level 1, level 1. You got all these different level 1 routers, which, what does level 1 mean? It means they know about the stuff that's in their area. Well, what about other areas? I mean, what about area 3? Well, level 1 doesn't care. It's saying, you know what? That's in another area. It doesn't concern me. If I ever want to reach whatever's over there, question mark, I will send it to the closest level 1/level 2 routers. Now, notice I didn't say I'll send it to the closest level 2 router. Right? Level 2 routers are backbone routers. Can you have a natively level 2 router? Well, sure you can, but it cannot speak to level 1 routers. That's where my men and women analogy broke down, right? Unless men and women never speak, which I guess we could make that argument in many cases. But level 2 routers are not compatible. They don't form neighbor relationships with level 1. Right? You have to have this little translator in the middle, essentially someone in an area that can speak to the level 1, receive those routes, and summarize that database into the level 2. So when you're thinking, well, what's the quote-unquote backbone area of ISIS, there is none. The backbone is the grouping of level 2 routers together. You can see that we've got level 2 linked to level 2 linked to level 2. That's the backbone, right? So essentially, just if we were thinking about routing tables, think of them as different routing tables or different databases of routes. You've got the level 1 database, which contains everything that's inside of that area, maintained by this router, who then passes it up to a level 1/2 router who says, okay, I see that database, and I will summarize that as I put it into my level 2 routes. Right? So it'll be a much smaller database that essentially would be a summary of what's in area 2, what's in area 3, what's in area 1. So the level 2s maintain all the summary, and they're the ones that hold the backbone together. So the routing algorithm of ISIS is all the level 1 routers try to find the closest level 1/level 2. Now, it's hang on, I want to make sure I emphasize this. Level 1, level 2 is not called an ABR. This is an OSPF term. I just put it there because that's the closest analogy I can draw to ISIS is these level 1/level 2 routers are like the ABRs of OSPF. Now you might wonder, what do you mean by the closest level 2? Like, how does it find that? Well, that's the cost, essentially the metric that ISIS uses. Remember, with OSPF, the bandwidth, or I shouldn't say the bandwidth, the metric, or the way OSPF finds the best way around, that's the way I should say it, is cost equals 100 divided by bandwidth in megabits per second, right? That's how OSPF figures out. So it looks at the link and says, oh, you're a T1 line, you're 1.5 megabits per second, divide that into 100, oh, okay, you come out to about 64 cost-wise. ISIS, much simpler. It's a number. Thank you. It doesn't mean anything. By default, everything's 10, right? So essentially, out of the box, ISIS is no better than RIP. Right? It's kind of like a hop count unless you come in and tweak it. So you have to create your own little schematic with ISIS of what do things cost. So I would come in here and say, well, that's a T1 line. What's T1 line mean to me? Well, for me, it means 8, right? Well, actually, probably not. That's pretty low. I would say for me, it means 43. Right? You know. Okay, so you would make an Excel spreadsheet somewhere, right? To where you would have these different values. Okay, well, a 10 megabit per second Ethernet link is a cost of, we'll say, 31. Okay, so now this does pose integration problems. If you ever take over a company and try and merge the networks with ISIS involved, their spreadsheet may not match your spreadsheet. They may say, well, a gig link for us is 25, whereas a gig link for you is like 3, so you have to kind of come together and figure out what strategy you want to use for that, but it is just a number, and you set that on a per interface basis. Now, if you're like me, you might scratch your head when you look at that network design that I just showed you and say, well, how does that relate to a service provider? So I put this picture together of what I would say would be a typical service provider design using ISIS. First off, notice the area 51, area 2, area 105, area 100. There's no area 0 as if we're working with OSPF, right? As long as you have a continuous working through the system level 2 backbone, that's all ISIS requires. You can't have a break in the backbone. It's paralysis, right? So that's the only requirement of the backbone with ISIS. So let me describe this picture to you. We have area 51, Rockwell. Huh? Why did I just forget where area 51 is? Rockwell, right? Aliens. Creepy things. This is the POP that the service router is using to service that area. So, this, again, let's think physically. Maybe this is a facility connecting to all these different customers over in New Mexico, right? I'll go with that. That's where area 51 is. So all these different customers connecting into here. So that then feeds into, we'll just say the backbone router for that POP, which trunks back. This is your SONET ring, and again, we're looking big picture here. The level 1 takes all of these different subnets and bridges them into the backbone in a summary route that then feeds into the backbone. Now I'm saying backbone area just because I've created an area 2 for the service router that has nothing but backbone routers. Essentially, there is no level 1 presence here. All they're receiving is summary routes at the core that then feeds all the different areas. Does this help describe it a little more? So all your individual customers, wherever these are, maybe this is another state, Arizona, this is Colorado. I'm just giving one potential here. Or maybe these are different cities in a metropolitan area that's grown large enough for you that you have all these different customers that you need to summarize. So this is how we would design the ISIS network for this. So I'm thinking if there's anything else I want to add here. I think that's it. Last thing I want to end with is a side-by-side comparison of OSPF and ISIS, because as a carrier, you'll likely run both in different areas of your network. I haven't seen any carriers yet that run natively everywhere one or the other. So first off, OSPF and ISIS, round 1 on the boxing tournament, both are link state protocols. They both use the concept of areas, although OSPF is different because it has the backbone area 0, that everything has to tie to. ISIS is a lot more flexible, and you can see that by seeing those diagrams to where you can stretch that backbone as far in your network as you want to stretch it, but you have that one backbone, essentially database that stretches everywhere. They have the concept of topology tables or link state databases, essentially where they maintain the entire routing database for their area, and that's the level 1 guys. Neighbor relationships, hello packets, everything like that. They have the concepts of routing tables. They run the SPF algorithm to find the best way around the network. Okay, so these are common ground. Now, differences. OSPF, the interfaces belong to areas. You remember earlier in the series when we did the OSPF configuration, I added interface by interface, either using the network command or by going under the interface itself and saying you are in area 0. With ISIS, the entire router belongs to an area. So in OSPF, it's very common with an area border router to see a diagram where you have these areas cutting it in half, or this guy's in 3 different areas, area 0, area 1, and area 2, to where it's got a interface in each one of these areas. In ISIS, that picture doesn't work that way. It works similar to what you saw on the previous slide, where the entire router belongs to an area. OSPF, all the areas tie back to the backbone. ISIS, you know this, the backbone runs through all areas with that level 2 database. Okay, so round 2. Now round 1 was virtually a draw, which is kind of like, okay, this is how they do things. Maybe ISIS has a little edge because of its flexibility with the backbone. So round 2. OSPF supports more area types. What does that mean? It supports area types like stubby, totally stubby, not so stubby areas, not so stubby, totally, NSS, what would that be? Not so stubby, totally stubby area. So essentially these are areas that have personalities. They filter routes differently. For instance, stub areas filters any route outside of the system. Totally stubby filters any route outside of the area. So it makes the area more efficient. So it makes it easier to essentially optimize an area out of the box. OSPF supports a metric scaled by default. I just told you you've got the cost equals 100 divided by bandwidth. With ISIS, you actually have to go and manually set your own standards for the metric because it's just a number over there. OSPF is supported by more vendors, and I'll say even more iOS flavors. ISIS is not in all iOS platforms. It's seen as a service provider feature, so you may have to pay more for your image to get it. And lastly, and I would probably say the biggest one, OSPF is well understood by the majority of the industry. It's an easy protocol. It speaks the native language of TCP/IP, which we spend years learning. We know it. We love it. So we have OSPF. All right, bing, 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 round 3. It seems like OSPF is coming out as the clear victor, but ISIS handles updates more efficiently. Okay, so now we're talking something tangible. It's not just, oh, I know that better, like OSPF. It's saying, okay, it handles it more efficiently. Well, how does it handle it, Jeremy? Well, ISIS rarely runs the SPF algorithm. The SPF algorithm is great. That's what OSPF's core is built on, is shortest path first, but it's not as efficient as ISIS because ISIS can run this new partial route calculation algorithm. Remember I said ISIS is like a train that is trying to find the best way to all the CLNS addresses in the network. That's essentially the OSI addresses of the routers. And in its little cart that it's toting behind it is the TCP/IP routes. Well, SPF calculates the best way around the network for all of these guys, but there's actually very few of them. It's a very small routing table because it's the router as a whole. Right? Compared to TCP/IP, which they created the partial route calculation, PRC, for. So if a TCP/IP route changes, without the foundation SPF structure or foundation routing structure, like routers aren't going down, things like that, then it only has to run the partial route calculation. So first off, more efficient algorithm that runs, and the SPF, the one that does run SPF, now you might be saying, well, good grief, why would a network go down without a router going down with it? Well, it's definitely possible, right? Disconnect a cable and there you go. But the SPF algorithm can run much faster because it's a much leaner, smaller database because it's just tracking the routers as a whole, not individual routes of TCP/IP. So ISIS by default is much faster to detect failures and converge. ISIS has less design constraints, meaning it doesn't have that area 0 backbone that we have to connect to, and it's very easy to adapt. As a matter of fact, it was ready for IPv6 long before OSPF version 3 came out because what do you have to change? ISIS stays the same. You just change the kind of things that can be carried in that little train car, which it was already designed for to begin with, and you have it compatible with IPv6. So you're like, well, I don't know. Which do I choose? Who's the clear victor here? I can't say. It really depends on your environment as a whole. What are the strongest advantages? Strongest one in terms of OSPF is its ability to be widespread, meaning almost everybody knows OSPF. It's easy to figure out. I mean, compared to ISIS, so it's widespread knowledge. I mean, why do you think Cisco invests millions of dollars in these certification programs? Well, they know that you're going to go buy whatever vendor you know, right? So if they get you certified in Cisco, I'll admit it, I walk into a network and I see a bunch of heathen equipment there. I'm like, oh man, you got to upgrade to Cisco. And they go, why? Because Cisco's the best. But inside I'm thinking, I don't know how to set up heathen router. It's like I don't want to have to learn Vieta. So I just threw an open source one out there just so I could stay vendor neutral and not slam it. Okay, Netgear. I'll just slam them for fun. I don't want to have to learn Netgear or deal with that equipment. So I want Cisco everywhere. That's the idea, right? So what's ISIS strongest piece? This one, and I would say kind of this one. Years ago, you would say, oh man, look at that. Our routers are really impacted by the efficiency. But I mean, talk about these protocols. I mean, we're talking protocols that are decades old. We're talking Jeremy's with his Commodore Amiga learning the ropes of computing, and they're rolling out ISIS and OSPF, right? Like that's the kind of age on these. So how many processor cycles it saves isn't as big a deal nowadays because our routers are so powerful compared to what they once were. So I hope that gives you a good overview of what is this protocol, how the design differs from OSPF with that backbone, that level 2 database concept, and then comparing this to OSPF and seeing the clear advantages of one over the other. I think that a lot of the pieces, because I'm sure if I was putting myself in your shoes and thinking, okay, would I feel good? I would feel good about the big picture concept of ISIS and how things connect together, kind of the database, but know that a lot of this will come together once we look at the configuration in the next nugget. I hope this has been informative for you, and I'd like to thank you for viewing.